Alright, team. So I left you hanging in class, and I did that intentionally, partially because I wanted to save some time and I wanted to introduce a kind of complicated problem, but I didn't want to kind of bog you down with it right before we went into the quiz. So I left it for this video. So in this video, I'm going to talk about finding the domain of this problem, g of f of x, where g of f of x is the square root of 3 minus x plus 1 over x minus 2. Okay. So one thing we know from f of x, we already knew that we have a restricted domain where x can't equal 2, and we see that that's going to show up here as well. We don't want to be dividing by 0, so we need to take out 2 from our domain. Okay. And later on, we'll show in the graph kind of what the difference between the issue where you're dividing by 0 versus where you have a root that you don't want negative. And that's the other part of this that we're going to restrict. So we have an even root, we have a square root, and we don't want to have the input of our square root, the thing under the radical, we don't want it to be negative. The reason for that is that if we put something in that is negative, what we get out from that is going to be an imaginary number. And that's okay, except we're trying to graph this and see where it is on a real number coordinate plane. Okay. So imaginary numbers are just fine. We're just, for this problem, restricting ourselves to a coordinate plane of 2 real number lines. Okay, so what we're asking is that whatever's inside that radical is not negative, or another way to say that is that stuff inside is greater than or equal to 0. Now you might be inclined at this point to either add that fraction to both sides or subtract 3 from both sides, and that's a fine inclination. The reason I'm not going to do that, you'll see later on, I like to have my equation or my inequality set to 0, because if it's compared to 0, then I can do some nicer things in terms of dealing with positives and negatives, and that's going to show up later. So instead of moving one of my terms to the other side of the equation, what I'm going to do is find a common denominator. Now, obviously, I can multiply that 3 by 1, and it doesn't change the value of my inequality at all. So instead of writing 1, I'm going to make a 1 that's a little fancier, right? Anytime we have the same numerator and denominator, if it's not 0, that we get a value of 1. Okay? So I chose x minus 2 over x minus 2 because that gives me a common denominator. So let me move that up. And then I'm going to go ahead and multiply through. So now I'm subtracting x plus 1 over x minus 2 from that first term. And so I can put that together under one denominator. Because it's a common denominator, I can combine those. And the thing to remember here is that I'm subtracting the whole x plus 1. Move that up. So that's the same as subtracting x and subtracting 1. So I've kind of simplified there, distributed my negative. Now I'm going to combine my like terms. Okay, so now I'm in a good place to start figuring out what x values are going to be allowable and which ones are not. And one thing I want to think about is when I'm looking at a fraction, so in this case I want my fraction not to be negative, or it can be either 0 or it can be positive. So I know that my denominator can't equal 0, so I already dealt with that. So for a fraction to equal 0, the numerator has to equal 0 and the denominator not. If I want a positive number, a couple different things can happen. I could have a situation, let me move that up. I can have a situation where the numerator and the denominator are both positive, right? Well, like we said here, we have to have a strict inequality. We have already taken out 2, so that's not going to be an option. So I have two positive options, right? A positive numerator, a positive denominator, to make a positive fraction. But remember, I can also make a positive fraction from a negative numerator with a negative denominator. So I can actually look at both these things, and I have to look at both sides. Those two options are still viable, right? So I'm going to manipulate those equations a little bit, and then I find out on one side I have a situation where x has to be greater than or equal to 7/2, also while being greater than 2. Or on the other side, x has to be less than or equal to 7/2 while being less than 2. So let's look what that looks like on a number line. Move that up. All right. So first we'll look at the left-hand side. Notice in red we have the x is greater than or equal to 7/2, and notice we have that kind of filled in circle. That's the equal to part. And then we have the x is greater than 2 with an open circle. Now remember that these both have to be true at the same time. That's what we call an intersection. That and means an intersection. It means altogether we're going to only use the parts that are true for both of them at the same time. So that black line with the dot, with the filled in dot, represents all the places where they're both true. Okay? And then looking at the other side, we have x is less than or equal to 7/2 in the red, and x is less than 2 in the blue. And where those two overlap, that's the intersection where they overlap. We have then, of course, just x is less than 2. So now remember that though these ands represent intersections where they both overlap, either of those two things could be true. I could have a positive numerator with positive denominator, or I could have a negative numerator with a negative denominator. Either of those options are fine. So that's an or situation, and so that's what we would make a union. So now I have a union of these two pieces. Now we'll look at the graph as we compare it. And so in purple you see the graph of our function g of f of x. Now notice how the graph shoots off to infinity as you get close to 2, and how when you get close to 7/2, it just goes to that point and stops. Now if we try to push our x values, our input values, a little less than 7/2, our outputs would have to shift into the imaginary realm, so they wouldn't show up on this graph. That's the reason. You could think of it as pushing in a third dimension, but they don't show up on this graph. Right. So another way to write this domain is as negative infinity to 2 union inclusive 7/2 to infinity. Right. I hope that was helpful. One thing I want to remind you of when you're watching videos like this where someone's working through a problem, once they've set up the problem, pause the video, try to work through as much as you can, exhaust all your resources before you get frustrated, and then if you feel stuck and you've tried different options, go ahead and unpause the video, let it push you through the stuck part, then pause again and try to continue, and repeat that process until you've done it. That's the best way for you to kind of develop those mathematical muscles and get more familiar with solving problems without getting frustrated, but also without just letting yourself think that you understand something when you haven't quite